Welcome to Tech and Trek, exploring the past, powered by the future. Everybody is looking for the secrets hidden beneath the ice. Antarctica, the southernmost continent, stands as a frozen sentinel at the edge of our world. Beneath this frozen wilderness lies a secret that has captivated scientists and explorers alike. Imagine this icy desert transformed into a lush, green rainforest teeming with life. Fossilized plant material, preserved for millions of years, tells a story of a verdant past. These ancient rainforests provide invaluable insights into our planet's climatic history. The journey to uncover Antarctica's ancient rainforest began with meticulous scientific inquiry. Researchers drilled deep into the ice, extracting cores that contained layers upon layers of history. These ice cores are like time capsules, preserving the past in their frozen depths. Each layer tells a story, and within these stories, scientists found evidence of a world long gone. Among the most compelling finds were the fossilized roots and pollen grains, remnants of a thriving rainforest. These ancient clues were painstakingly analyzed using advanced techniques. For instance, scientists used radiometric dating to determine the age of the fossils, revealing that they originated from a time when dinosaurs roamed the Earth. This process involves measuring the decay of radioactive isotopes, providing a precise timeline of the rainforest's existence. Moreover, the analysis of these fossils extended beyond mere dating. Researchers conducted paleoecological reconstructions, piecing together the ancient ecosystem in exquisite detail. By examining the types of plants and their growth patterns, they were able to infer the climate conditions of the time. This deep dive into the past has shed light on how Earth's climate and biosphere have evolved over millions of years. The implications of these findings are profound. They suggest that Earth's climate has undergone significant shifts, transforming a warm, forested Antarctica into the icy expanse we see today. This knowledge not only enhances our understanding of the past, but also serves as a vital tool in predicting future climate trends. By studying how ancient ecosystems responded to climate changes, we can better anticipate the impacts of current and future global warming. The discovery of fossilized rainforests beneath Antarctica's ice began with a stroke of serendipity. Scientists were studying ice cores for climate data. They stumbled upon something extraordinary. Deep within these ice cores, they found fossilized plant material. This unexpected find sparked excitement among the researchers. The ice cores revealed layers of history compressed over millions of years. They identified pollen grains and fragments of ancient roots. These hinted at a lush, green rainforest. The realization was astonishing. The news ignited enthusiasm within the scientific community. The scientific community reacted to the discovery with a mixture of excitement and skepticism. On one hand, the idea of a prehistoric rainforest beneath Antarctica's ice was thrilling. It challenged long-held assumptions about the continent's climatic history. On the other hand, such a groundbreaking finding required rigorous verification. Scientists were eager to validate the discovery through thorough analysis and peer review. Initial studies focused on the integrity of the fossilized material. Researchers had to ensure that these were indeed ancient remnants and not modern contaminants. This involved meticulous examination of the pollen grains and plant fragments, using state-of-the-art techniques to confirm their age and origin. The results were conclusive. The fossils were authentic and dated back to the Cretaceous period. With the authenticity of the fossils established, the scientific community began to explore the broader implications of the discovery. Paleobotanists analysed the types of plants found, reconstructing the ancient rainforest's biodiversity. Geologists examined the sediment layers to understand the environmental conditions that preserved these fossils. Climate scientists used the data to refine their models of Earth's past climate, gaining new insights into how the planet has evolved over millions of years. The implications extended beyond academic curiosity. The ancient rainforest offered a unique window into a period of Earth's history when atmospheric carbon dioxide levels were much higher than today. Studying this prehistoric ecosystem could provide valuable lessons for understanding the potential impacts of current climate change. This knowledge is crucial as we seek to mitigate and adapt to the challenges posed by global warming. As researchers delved deeper into the ice cores, they uncovered a treasure trove of information about the ancient rainforest. The fossilized plant material included not only pollen grains and roots, but also leaves, wood, and even spores. Each piece of evidence added to the growing picture of a vibrant, diverse ecosystem that thrived in a much warmer Antarctica. The leaves, remarkably well preserved, provided clues about the types of vegetation that flourished in the Cretaceous period. Some of the most significant finds were the remnants of ancient ferns and conifers, plants that are now largely associated with more temperate climates. These fossils indicated that the Antarctic rainforest was composed of a mix of flora, some of which are still found in today's tropical and subtropical regions. Paleobotanists were particularly excited about the discovery of wood samples, which allowed for detailed analysis of the trees that once dominated the landscape. By studying the growth rings in these fossilized trees, researchers could infer the climatic conditions of the time. The evidence suggested that the region experienced warm temperatures and high precipitation, conditions conducive to lush, dense forests. In addition to plant material, scientists also found traces of ancient soils and sediments. These layers provided further context for understanding the environment in which the rainforest existed. By analysing the chemical composition of the soils, researchers could reconstruct the nutrient cycles and ecosystem dynamics that supported such a rich biodiversity. This comprehensive study of the ancient rainforest has offered invaluable insights into the interplay between climate, vegetation, and geological processes. The initial discovery set the stage for a series of exploratory expeditions to Antarctica. Teams of scientists embarked on missions to collect ice cores and evidence of the ancient rainforest. These expeditions faced harsh weather and logistical challenges. Despite obstacles, the expeditions yielded significant discoveries. Researchers drilled deeper, uncovering more fossilized material. Each find added to the evidence of the prehistoric rainforest. The data was meticulously catalogued and analysed. The scientific community's collaborative spirit was evident. Researchers from different fields shared their expertise. This interdisciplinary approach was crucial. Paleobotanists, geologists, and climate scientists all contributed. The evidence mounted, revealing Earth's past climate. The ancient rainforest offered insights into Earth's history. Understanding this ecosystem could help predict future climate change. The initial steps opened a new frontier in climate science. The research into Antarctica's ancient rainforest required a sophisticated array of scientific methods. At the forefront was the process of drilling ice cores, which involves extracting cylindrical samples from deep within the ice sheets. These ice cores serve as time capsules, preserving layers of snow and ice that have accumulated over millennia. Each layer represents a distinct period in Earth's climatic history, making ice cores invaluable for paleo-environmental studies. Once extracted, the ice cores undergo meticulous examination. Scientists employ advanced imaging techniques to identify and catalogue the fossilized plant material embedded within these layers. Microscopic analysis is crucial, as many of the fossils are minuscule, such as pollen grains and spores. High-resolution microscopes allow researchers to study these tiny specimens in detail, revealing their structure and composition. In addition to microscopic analysis, scientists use spectroscopic methods to determine the chemical signatures of the fossils. Techniques like mass spectrometry and X-ray fluorescence provide insights into the elemental composition of the plant material. These analyses help researchers infer the environmental conditions that prevailed when the plants were alive, such as temperature, humidity, and atmospheric composition. Another important method is the use of stable isotope analysis. By examining the ratios of different isotopes within the fossilized material, scientists can reconstruct past climatic conditions with remarkable accuracy. For instance, the ratio of oxygen isotopes in plant tissues can indicate ancient temperatures, while carbon isotopes can reveal information about the carbon cycle and atmospheric CO2 levels during the Cretaceous period. Radiometric dating has been a cornerstone in establishing the age of the fossilized material found in Antarctica. This technique involves measuring the decay of radioactive isotopes within the fossils. By calculating the rate at which these isotopes decay, scientists can determine the age of the specimens with a high degree of precision. For the Antarctic rainforest fossils, radiometric dating confirmed that they originated from the mid-Cretaceous period, approximately 90 million years ago. Beyond dating, paleoecological reconstruction has been key to understanding the ancient environment. Paleoecology involves studying fossilized remains to infer the characteristics of past ecosystems. By doing so, they can reconstruct the biodiversity and ecological dynamics of the prehistoric rainforest. The diversity of the plant life suggests that the Cretaceous Antarctica was a complex and thriving ecosystem. Reconstructing the ancient ecosystem of Antarctica requires a multidisciplinary approach. Scientists from various fields collaborate to build a comprehensive picture of the prehistoric rainforest. Their efforts begin with identifying and cataloguing fossilized plant material. Using fossil data, scientists simulate what the Antarctic rainforest might have looked like. The result is a vivid, scientifically accurate representation of the prehistoric ecosystem. Soil samples provide clues about the nutrient cycles and microbial activity that sustained the rainforest. By piecing together data, scientists create a holistic view of the ancient Antarctic rainforest. The study of Antarctica's ancient rainforest has been marked by global collaboration. Scientists share expertise and resources, overcoming challenges in this remote region. Future research aims to understand the transition from a warm, forested landscape to today's icy expanse. Each discovery expands our understanding of Earth's climatic and ecological history. The discovery of an ancient rainforest beneath Antarctica's ice revises our understanding of Earth's climatic history. The mid-Cretaceous period saw high CO2 levels and warm temperatures, supporting diverse ecosystems. This challenges the assumption that extreme climates always hinder biodiversity. Understanding this period helps refine models predicting future climate trends. Studying the ancient Antarctic rainforest reveals the impact of greenhouse gases on global temperatures. Fossilized remains suggest a stable climate with minimal seasonal variation. Growth rings in fossilized trees provide a detailed record of past climatic conditions. Warm ocean currents likely played a significant role in maintaining the region's warm climate. The ancient Antarctic rainforest highlights Earth's capacity for dramatic climatic shifts. High CO2 levels in the Cretaceous period corresponded with warmer global temperatures. Studying this period helps understand the long-term effects of increased greenhouse gases. The resilience of ancient ecosystems offers insights into how modern ecosystems might respond to climate change. Data from the ancient Antarctic rainforest refines predictive models for future climate scenarios. The Cretaceous period serves as a natural analogue for high CO2 levels. Understanding past climates helps predict potential outcomes of current trends. Identifying tipping points and feedback mechanisms informs climate policy and mitigation strategies. The ancient rainforest beneath Antarctica's ice has far-reaching implications beyond climate science. It challenges our perceptions of Earth's history and underscores the planet's capacity for rapid transformation. Similar discoveries in other extreme environments drive ongoing exploration. The discovery emphasizes the urgency of addressing climate change and preserving Earth's climate stability. Beneath Antarctica's ice lies a world of hidden marine ecosystems. Fossilized marine life could offer insights into the ocean's past and its role in global climatic systems. Advanced technology and innovative methods are crucial for identifying potential sites. Each expedition brings us closer to unveiling the mysteries of Antarctica's underwater past. Studying ancient microbial life beneath Antarctica's ice offers a window into the past. Extremophiles might reveal how life adapts to and endures environmental stress. Analysing these microbes enhances our understanding of biogeochemical cycles. This research informs astrobiology and predicts the impacts of climate change on microbial communities. The potential for finding prehistoric animal fossils beneath Antarctica's ice is tantalizing. Discovering dinosaur fossils would offer direct evidence of their presence in ancient ecosystems. Fossils of other prehistoric animals could reveal evolutionary history and biogeography. Each find contributes to a richer picture of life in ancient Antarctica and informs our understanding of biodiversity and ecological resilience. The revelations about Antarctica's ancient rainforest underscore the importance of continued exploration and research. As technology advances, so too does our ability to uncover the secrets hidden beneath the ice. The future of Antarctic exploration promises to be thrilling and transformative. Mapping the ancient rainforest and other ecosystems is a primary goal. Advanced remote sensing technologies will identify areas of interest. Detailed geological surveys and ice core drilling are essential. Collaboration will be key to future success. International teams with diverse expertise will lead these efforts. These collaborations will enhance research quality and scope. Future exploration aims to expand beyond terrestrial ecosystems. Discovering ancient marine and microbial life opens new frontiers. Innovative approaches and technologies will push research boundaries. Knowledge gained will have profound implications for understanding climate change. Studying ancient ecosystems helps predict and prepare for future changes. Antarctica's secrets hold solutions to pressing challenges. The future of Antarctic exploration is bright, with potential for groundbreaking discoveries. The ancient rainforest is just the beginning, a glimpse of many secrets. Preserving and studying our planet's natural history is crucial. The discovery of Antarctica's ancient rainforest is a monumental milestone in our understanding of Earth's climatic history. It serves as a stark reminder that our planet is capable of profound transformations. This revelation underscores the dynamic nature of Earth's climate system. By studying this prehistoric ecosystem, we gain invaluable insights into past climate changes. These insights help refine predictive models for future climate scenarios. This discovery also highlights the resilience of Earth's ecosystems. Life's ability to flourish in harsh environments provides hope as we face the climate crisis. The ancient Antarctic rainforest ignites curiosity and passion for scientific inquiry. Each new discovery has the potential to transform our understanding of Earth's history and future. The unearthing of Antarctica's ancient rainforest is a scientific triumph and a call to action. The lessons from this ancient world will guide us in navigating climate change. The ancient rainforest beneath the ice stands as a testament to the enduring power of science. Thank you for watching Tech and Trek. Don't forget to like, share, and subscribe for more explorations into the past, powered by the future.